What is a transformer? A transformer is a device which converts the size of the voltage, or converts voltage, to a lower or higher value. And where are they used? They're used on our national grid system. And they're used to either step up, so you're always talking in terms of voltage here. So stepping up is increasing voltage, or step down is decreasing voltage. So the electricity gets to your home from the power station via a step up transformer. The national grid is a system of cables and pylons and so on. It's stepped down close to your home, and then it's sent to homes, businesses and factories. Now this is a reason why we use transformers. When electrical current flows, you get heat in a conductor. A higher current means more heat. So if you have a high current, you have more heat produced. So what happens when the current flows along the cables? Well, the heat is lost in the form of energy, or in the form of heat into the atmosphere. So how do they prevent this? The current is reduced, because when you have a high current you have more heat loss. So they reduce the current before it's transferred to the national grid. And to do this, they have to increase the voltage. So the voltage has to be stepped up. Okay, so when you reduce current, you have to step up the voltage. And this is the reason why voltage is stepped up. In this way, less energy is lost. Because if you have your wires and you've got heat going out into the atmosphere, it's not been used for anything. It's just dissipated to the atmosphere and lost. Right, so if you saw in one of those last slides there that the voltage that might be on your wires might be about 132,000 volts. That's obviously not a suitable value to go into your home. So then when it gets to your home, a school or a factory, the voltage is stepped down. And that's just to give it a suitable value for you to use in your home. Right, now, to use a step-up transformer, what you have are two coils of wire. And those two coils of wire are connected by a piece of iron, and it's generally in this shape here. And that piece of iron intensifies the magnetic field, if you remember that. So this is iron. Now, on your two pieces of iron here at the sides, you've got two coils. The one on the left is a primary, and it's the one that the voltage is fed into, and that voltage is always alternating. The second one is the secondary, and this is a voltage that comes out. So when you step up or step down, this is what you want to come out, either a bigger voltage or a smaller voltage. It also produces alternating voltage. If you want to step up your voltage, you use a secondary coil which has more coils than the primary. And that steps up your voltage. Okay, so if you want to step up, you must draw, or you must have more coils on your secondary coil. If you want to step down, however, you must have more turns. Again, it's alternating current. It only works in alternating current. You must have more coils in your primary coil than on your secondary coil. The reason it must be alternating, if you remember way back to electromagnetic induction, whenever you have an alternating current on your first coil of wire and your second coil sitting beside it, you can only get current induced in your second coil if there's a change happening in the first. So you need a change happening. So we imagine the direction of this change in north, south, changing there, continually changing direction. And that induces a continual current on your secondary coil. So this won't work on DC. If you have a DC current there, it won't work. And the reason is because you always have to have a changing magnetic field around your primary coil for that to happen. Now we've got an equation, of course, in physics we always have equations, and the size of the output voltage depends on the ratio of the turns on the primary and secondary coils. So if you have 5 times the number of coils on your primary than you have on your secondary, then you're going to also have 5 times the voltage in your primary than you have in your secondary. Now you can use this equation or you don't have to use it. It will help in an exam though if you write it down, because then even if you don't get the answer right, at least you've got the equation right and you will be credited with at least 1 mark. Okay, so a transformer has 200 turns in its primary coil and 50 turns in its secondary. The input voltage is 920. So if I just write down the equation here again, the voltage in your primary over the voltage in your secondary equals the number of turns in your primary over the number of turns in your secondary. Is it a step up or a step down? So you can see 200 in the primary and 50 on the secondary. So it must be a step. So right, a step down transformer. It has to be a step down because it's gone down from 200 turns down to 50. Okay, so what is the output voltage? Now it's up to you what way you do it. I'm going to write the numbers into the equation. So our primary voltage there is 920 volts. So I'll write down VP equals 920. We're looking for VS, we don't know it. We know that the number of turns in the primary is 200. And we know that the number of turns in the secondary is 50. Right, so I'll do it as an equation and then I'll show it to you as a ratio, and very often people find that a little bit easier to be shown as a ratio. If we put everything into the equation up here, we have 920 over VS is equal to 200 over 50. Okay, so you can actually see that this has been stepped down by a ratio of 1/4. It's going down from 200 to 50, so will this, the 920. And if we do that, we find that VS equals 230 turns. Now, of course, or 230 volts. Of course, you could do this by rearranging the equation. And if you did rearrange the equation, you would end up with the secondary voltage is 920 times 50, and then it's all divided by 200. So we just look at the ratio idea. You've got 200 to 50, and you can see that goes down to ratio 4:1. So you know that you had 920 volts, and you need to go down at a ratio of 4:1. So you just divide that by 4 to get your VS, and VS equals 230 volts. So that's the ratio idea if you want to do it that way. You will generally be credited some marks for doing it as a ratio idea, and if you get it right, you will definitely get all the marks. Right, the last one, transformer question 2. A transformer has 100 turns in its primary coil. So we'll write this down. So number of turns in the primary coil is 100. It has an input voltage, so 35 volts, and an output voltage of 175. So again, if you want to do it as a ratio idea, if you do 35 to 175, and if you divide that, you find that 35 goes in 5 times, so that's a ratio of 1 to 5. And so then if you do this also for your number of turns, you've got 100 to NS, and therefore you're multiplying by 5, so NS must be 500.